This is the Pearson's Edexcel GCSE Mathematics Paper 1 exam for the higher tier with regards to the summer of 2017. So we'll start with question 1. So it says that the scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. And it says one of the points is an outlier. Write down the coordinates of this point. So I think we can agree it's going to be this one here because it lies outside of this general trend. So if I look at the graph, I can see that each square here represents an increase of 0.2 as we go to the right. And then on this axis here, the y-axis, I will have a same thing, 0.2 increase as it goes up. So if I read the graph carefully, I will notice that I get 10 and 19. So for all the other points, write down type of correlation. So we can see that as one increases, so does the other. So that means it's going to be a positive correlation. So it says on the same day in another British town, the maximum temperature was 16.4 degrees Celsius. Estimate the number of hours of sunshine in this town on this day. So let's go to 16.4. So we can say it's approximately that line. So if we were to draw a straight line and come back down, it'll be around 2.8, 2.9, but obviously it depends on how you draw your straight line. So as long as you've drawn a reasonable line of best fit, then you should get, I saw 12.8, but I think you could have anything from 12 to 13 as a justifiable answer. So a weatherman says the temperatures are higher on days when there is more sunshine. So does the scatter graph support what the weatherman is saying? And you have to give your reason. So in this case, we've already said that it's a positive correlation. So yes, because positive correlation. So, question 2, express 56 as a product of its prime factors. So 56, so let's break it out. Use a factor tree. So the first thing is 2, 28, then 2, 14, then 2, 7. So we circle, so circle the 2 and circle the 7 because now we ended up with simply prime numbers which can no longer be simplified or broken down. So how many 2's do we have? 1, 2, 3. So 2 times 2 times 2, and then we have 1, 7 equals 56. So we can write this as 56 equals 2 to the power of 3 times 7. So either or. Okay, question 3. So we have 54.6 times by 4.3. So if we want to work this out quite easily, what we can do is we can say, let's change these numbers. So 546 times by 43, so we've simply times by 10 here and times by 10 here to give us these numbers. So the next thing we can do is simple manual multiplication. So this is one of the ways in which you can do it. So 8, put the 1 there, 4 times 3, is that 13, put 3 there. Then 3 times 5 is 15 plus 6 there, and 0. 4 times 6, so 4. So we get the 2 there. 4 times 4, 16 plus the 2 gives us 18. Add the 1 there. 4 times 5 is 20 plus that one gives us 21. So we have 8, 7. So here we have 14. So 4, put the 1 there. So 3 and 2. So remember, we've multiplied by 10 on both numbers. So here we divide by 100 to get our answer, which is 234.78. Question 4. The area of square ABCD is 10 centimeters. So show that x squared plus 6x equals 1. Right. So we know the area of this, so ABCD, is 10 centimeters squared. So the area of the square we know is length times width. So we have 3 plus x, which is AB, so 3 plus x. And the same thing here, 3 plus x. So times those together. Ooh. Doesn't matter which way you put them, because remember, with regards to addition, it's commutable. So doesn't matter if it's 3 plus x or x plus 3. And we know this is equal to 10. So let's start multiplying out and let's employ our handy claws, our arrows. So we have x, so 3 times x, which is 3x, and then 3 times 3, which is 9, and then x times x is x squared, and then x times 3 is 3x, that equals 10. Then just writing this as follows, so collect the like terms, and then if we take this to the other side, it becomes negative. So we have 10 minus 9, which gives us 1, and that shows what we were asked to show. Question 5. Just going to change my color. The rectangle frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal frame. Right, okay, so first thing that we do is we need to figure out the length here. So we can see that this is a right angle triangle, so we can rely on our good friend Pythagoras. So if you remember Pythagoras, c squared equals a squared plus b squared. So in this case we're going to have 5 squared plus 12 squared equals c squared. Let's call this c squared. So this is 25 plus 144, which gives us 169. So if we square root 169, we get 13. Remember, we get a plus and a minus 13, but obviously because we're talking about physical space here, then it's going to be the positive 13. So talk about 13 here, and here is going to be 12, the same, and here 5. So let's add up the lengths. So 12 plus 12 plus 5 plus 5 plus 13, which equals 47 meters. And then 47 meters times, sorry, so times 1.5, so we'll get 47 times 1.5 equals 70.5. Okay, question 6. So it says the equation of the line L1 is y equals 3x minus 2, and the equation of the line L2 is 3y minus 9x plus 5 equals 0. Show that these two lines are parallel. Alright, so essentially when we see this type of question, what we want to show is that they have the same gradient, which will show that they're moving in the same direction. So L1 has an m, which is, remember, the letter that we use to represent gradient, equals 3, and then L2, so L2 is 3y minus 9x plus 5 equals 0. So let's rearrange this to make y the subject. So we move that to the other side, plus 9x, and then move that to the other side, minus x. 3y equals 9x minus 5, and then we divide by 3, so we get 3x minus 5 over 3, and lo and behold, you can see that we have 3 here, so m is 3 for L2 also. So we prove that they're parallel. Question 7. It says there are 10 boys and 20 girls in a class. The class is a test. The mean mark for all the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. Right, so we know that there's 30 pupils, and we are told that the mean mark for the entire class is 60. So that means they multiplied 30 by 60 to give us 1,800. We know that the mean mark for the girls is 54. So there were 20 girls, times that by 54 gives us 1,018. So what we need to do is subtract these two, and we'd get 0, 7, borrow that, 2, and 7. And so we know that there are 10 boys. So cancel, 72. So the mean mark for the boys was 72. Question 8. So it says write 7.97 times 10 to the power of 4 is an ordinary number. So we're going to have 0. So how many zeros are we going to have? So we move it once, and then we'll have minus 5 left. So we're going to have 5 zeros. And then we're going to have 7, 9, 7. And then B, work out the value of 2.52 times 10 to the power of 5 divided by 4 times 10 to the power of minus 3. So given in standard form. So one thing that we can do is we can write it out properly. Right, so the first thing we can say, let's take these values here. So let's take 252 and divide it by 2, divided by 4, which will give us 63. And here we can see that from the laws of indices, we'll have 5 take away minus 3. So law indices have 5 minus 3, which gives us 8. So because we divided this here by 252, which meant that we'd moved the decimal point to the right, i.e. multiplied by 100. So what we're going to do is move that answer 63 to 0.63, and we want to multiply it by 10 to the power of 8, and we can write 6.3 10 to the power of 7. Okay, question 9. So it says that Julius buys a washing machine. 20% VAT is added to the price of the washing machine. Julius then has to pay a total of £600. What's the price of the washing machine with no VAT? So if we say that the price of the washing machine plus the VAT is 600, and so the VAT is 20%, and of course the price of the washing machine is going to be 100%. So this is 120%. So we divide by 6, let's say. So if we divide by 6, we get 100, and then that equals 20%. And then so to get from 20% to 100%, we times by 5. So we get 100% here. And then if we times by 5, we get 500. So that means that without the VAT, the price is £500. Question 10, it says show that, and you have this here, can be, so it's expression, and it can be written in the form as follows, where A, B, C, and D are positive integers. Okay, so essentially you just want to expand the brackets. So let's start off with x plus 2, x plus 3. So I'm going to use my arrows for this one, and then this one here. So we get x squared plus 2x plus 3x plus 6. And then the one that we have left is x plus 1. I'll do it in a different color. So let me just do that. And then I'll do this one in a different color. So x plus 1 times all of this. 3x plus 6. So again, my trusted arrows, and I'll use a different color for the other arrows. So we'll get x cubed for this one, plus 2x squared plus 3x squared plus 6x, and then plus x squared plus 2x plus 3x plus 6. So if we add all of these up, we'll have x cubed. So we've got how many x squared? So 2, 5, 6. And then how many x? So we've got 6, 8, and then 11. And then we've only got plus 6. So that's our answer. Just write that out a little bit more neatly. Power of 3. Question 11. It says the graph of y equals fx is drawn on the function, drawn on the grid. So this is a function. Write down the coordinates of the turning point. So the turning point, as we know, is literally where the gradient goes from being 0 and changes its charge, if you like. So that's where the gradient is equal to 0. So that would seem 1 and minus 3. 1 and minus 3. Write down estimates for the roots of fx equals 0. So where fx equals 0, so fx is equal to y. So that means where this y equals 0, which is on the x-axis. So here it equals to 0, here it equals to 0. So I would say that looks to me to be minus 0.75, and then here and 2.75. Okay, and just be careful, I should have mentioned this earlier on, to just look at the graph scaling. So here you can see each square is worth 0.1 as you move to the right, or here minus 0.1 as you move to the left, whereas over here as you go on the y-axis up and down, you can see 0.2 per square. So just be mindful of that. So work out estimate for f 1.5. So x is 1.5. So if we come here, so 1, 2, 3, 4, 5, and then we scroll down, and then we go across, then we'll see that we have minus 2.8. So the next question is, find the value of 81 to the power of minus a half. So because we've got a negative power, what we could do is invert it. So 1 over 81 to the power of a half. Now remember that a power half, so if you have anything power half, it's the same as square root. So that means, what is the square root of 81? It's going to be 1 over 9. Find the value of 64 over 125 to the power of 2 over 3. So the first thing we can do is we can cube root. So let's cube root 64, and that's going to give us 4, because 4 cubed is 64. And then the same thing for 125, cube root, that gives us 5, because of the same logic. 5 cubed is 125. And then remember, we still have to square, so we have 4 over 5 squared, so 16 and 25. Okay, question 13. So the table shows a set of values for x and y. Here's your x, here's your y. Y is inversely proportional to the square of x. Find an equation for y in terms of x. So we know that y is inversely proportional. So it's going to be to the square of x. So when we should recall that whenever something's inversely proportional, then we'll have this this variable k here over a value, and in this case it's the square of x. Okay, so y equals k over x squared, and we can find out what our k is by just subbing in any one of these values. Okay, this let's go with this one. So we say 9 in place for y, k, and then 1 squared. So we get k is 1, so 9 equals k. So therefore, we're going to have 9 over x squared. So that means y equals 9 over x squared. So if we put that in there. Find the positive value of x when y equals 16. Right, so if y equals 16, 9 over x squared. So rearrange. So we multiply by x squared. So we get 16x squared equals 9. And then we divide by 16. Again, we're just rearranging to make x a subject. So we get x squared equals 9 over 16. And then because we have x to the power of 2, we just want x. So we get 3 and 4. Let me write that out more neatly. Okay, question 14. So it says white shapes and black shapes are used in the game. Some of the shapes are circles, all the others are squares. And then it gives you the information here. So there's quite a bit, and what I like to do is I'd like to highlight. So the white shapes to the black shapes is 3 to 7. And then the white circles to the white squares is 4 to 5. And then the black circles to the black squares are 2 to 5. So what fraction shapes are circles? So that's our task here. Okay, so how many shapes do we have? Well, there's a ratio of 3 to 7. So that means that there are 10 parts. So the white have 3 over 10. The black have 7 over 10. So this is shapes. And then we know that there's white circles and there's white squares of 4 to 5. So that means 4 over 9 is the circles. And then 5 over 9 is squares. And then here we have on the third line 2 over 5, 2 to 5. So we have 2 over 7 for the circle and 5 over 7 for the square. So if we want to figure out how many of the shapes are circles, so let's just separate this. So we can multiply 3 over 10 by 4 over 9. This will give us white circles. So that's 12 and 90. And then this is white circles. And here is black circles. So the same thing. So we've got 7 over 10 times by 2 over 7, which gives us 14 over 70. So just using a different color here to differentiate. So this here can be simplified. It can be simplified to 2 over 15. And then likewise 14 over 70 can be simplified to 1 over 5. And then 2 over 15 plus 1 over 5 equals 5 over 15. So if we change that to 3 over 15, and then this can be simplified to 1/3. So our answer is 1/3. Question 15. So a cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13 centimeters. Work out an estimate for the height of the cone. So you have the formula here. Let's zoom in slightly. So I have the formula here for the volume of a cone. So we know that, because we know that it's asking for an estimate, so we can change this to 100 and round this down to 5. So let's use the formula. So volume is equals 100. We have 1/3. It's asking for the radius. It's asking for pi. So we know that pi is 3.14. To do decimal places, we can change that to 3. So we put 3 in there, and then our r squared, so 5 squared, and then obviously we are trying to figure out h, so we leave it as that. So these two cancel each other. So I have 100 equals 25h. So if we divide by 25, we get 4 equals h, therefore h is 4. Now because we've estimated, remember this is just an estimate, but for our answer that will do. And depending on how you estimated the value will give you a different answer. I think this is perhaps the most inclined numbers to estimate for, but you might have something else that's also reasonable. For B, will your estimate, so John used a calculator to work out the height of the cone to 2 decimal places. So will your estimate be more than John's answer or less than John's answer? Give your working out. So the answer here will be that the actual, for me personally anyway, the actual height will be lower. The estimate will be more in my case. So let me write that down. So and this will obviously depend on what you've done. So the actual height will, and I'll explain why. So I rounded pi and r down. So essentially dividing by smaller number. Okay, so as you can see here, I estimated my r down and my radius down. So when I came to divide by my 5 squared, the number was smaller, and therefore, and also the number here, the volume 100, was rounded up. So if you have a larger number as a numerator and you're dividing by a smaller denominator, the number is going to be much larger, so the actual height will be lower. Question 16. So n is an integer greater than 1. Prove algebraically that n squared minus 2 minus, and then open brackets, n minus 2 close bracket squared is always an even number. So this is just proof. The first thing that we need to do is think about how we can show that something is an even number. Well, we know when we have an even number, it's going to be 2 times n. So anything multiplied by 2 is going to be even. So we want to show in this particular case that we're going to have 2 times some x, and we want to essentially derive that form from this expression here. So let's go about thinking how we do that. So n squared minus 2 minus, and I'm going to expand this. So we're going to have n minus 2, n minus 2, and then n squared minus 2, and then if I expand out, I get n squared minus 2n plus 4, and then I get n squared minus 2 minus n squared minus 4n plus 4. So literally all we've done here is we've expanded this and then collected the like terms, and then literally I can open up now this to the other part of the expression. So n squared minus 2 minus n squared plus 4n minus 4. So let's simplify. So that cancels with that. I get 4n minus 6. So now I can see that 4 and 6 are even. I can factor out a 2, which will give me 2n minus 3. So therefore, because there is a 2, that means that this is even. Okay, question 17. So it says there are 9 counters in the bag. 7 of the counters are green, 2 of the counters are blue. Ria takes out at random 2 counters from the bag. Write out the probability that Ria takes 1 counter of each color. You must show you're working out. So this is probability tree. So let's start off with 7 over 9, so that's green, and then 2 over 9, and that's red. So if you take out a green the first time, 6 over 8 left, which is green, so that's green 1, green 2, and then if it takes out a green, then it's going to be 2 over 8 for the red. And then if she takes out red the first time, 1 over 8, 1 over 8 for the red, and 7 over 8 for the green. So red 1 there, green 1, and red 2. Right, so it says work out the probability that Ria takes one counter of each color you must show you're working out. So if she takes out a green and then a red, so that's 7 over 9 times 2 over 8, which gives us 14 over 72. And then here, if she takes out a red and then a green, that's 2 over 9 times by 7 over 8, which is 28 over 72. Sorry, that's 14, I should say, over 72. If we add those two together, we get 28 over 72. So we can simplify this. That would give us 14 over 36, which gives us 7 over 18. So the answer could be any one of them, but we'll go with the most simplified. Question 18. So ABCD is a rhombus. The coordinates of A are 5, 11. The equation of the diagonal DB is y equals half x plus 6. Find the equation of the diagonal AC. Right, so we know that the gradient here of dB equals a half, because it tells us, and then the gradient of AC is going to be minus 2, because it's going to be perpendicular. So if this is dB, here, then AC is going to be perpendicular. So remember, if you multiply two perpendicular gradients, you get the product of minus 1. So therefore we're going to have y equals minus 2x plus c, which is gradient of line. Is the equation Okay, question 18. So it says that ABC is a rhombus. The coordinates of A, which is here, are 5, 11. The equation of the diagonal DB, so that's that there, is y equals half x plus 6. Find the diagonal of AC. Right, so essentially we want to find the equation of this line, which corresponds to the diagonal here, which is AC. So we're going to use this form, equation of the line. So how can we find m first and foremost? Well, we know that since we have this line here, dB, with gradient half, this line AC is going to be perpendicular to that. Okay, so if you remember, if we have m1 times m2, where these two lines are perpendicular to one another, you'll get minus 1. So therefore, m2 in this case will be minus 2 x plus c. So we know that the coordinate A, 511, lies on the line AC, of course. So we can substitute that value in. So we say 11 equals minus 2, 5 plus C. So 11, because it's going to be minus 10, if you take it to the other side, it's going to be a positive, equals C. Therefore, C equals 21. So we're going to have 11 equals minus 2x plus 21. Okay, question 19. So this is a bit of a long question, but let's work through it. So we have this parallelogram. It tells us that x is the midpoint of the line AC. So I'm just going to put x there. And it says that OCD is a straight line. So OC, and then I'm going to just put line D there. And it gives us XD equals this. And it wants us to find the value of k here. So the first thing that we need to do is appreciate that the vector AC equals minus a plus c. So minus a plus c. Then we have xc, which equals minus half a plus half c. So because remember, this is the midway point of AC, so you have half minus half a, and then plus half c. And we know that xd equals xc plus cd. So xc to cd. We know what xc is from here. So let's sub that in. So minus half a plus half c plus cd. We know what xd is because it tells us here. So 3c minus half a. So all we need to do is some rearranging. So we have the cancelling of minus a halves, and then we take that to the other side, so that becomes a negative. So we've got 3c minus c over 2 equals cd, which is 5c over 2 equals, should put that as a vector, cd. Now OC, the vector, to CD, okay, we want it in the form, well, we're going to have 1 OC to 5, 2. So from the origin to C is going to be C, and then from C to D is going to be 5, 2, we just worked out. But we want it in the form of K, 1. So to get from 5, 2 to 1, we have to subtract 3 over 2. So same thing on this side. So we're going to have 2 over 5 to give us 1. Okay? And therefore, our answer is going to be 2 over 5. Okay, question 20. So it says solve algebraically the simultaneous equations. X squared plus y squared equals 25 and y minus 3x equals 15. Now I know this is going to be quite a lengthy process, so I'm not going to use the sheet itself. I'm going to write on a different program. So let's start off with x squared plus y squared equals 25. Then y minus 3x equals 13. So this is my 1, this is my 2. So if I want to solve it algebraically, well, I know that I'm going to want to substitute one into the other. I've got squares here, so I don't want to have to start rearranging to find x or make y the subject. So I'm going to come to 2 here. That's my go-to, which I'm going to substitute into the other. So if we rearrange this, make y the subject, we get 3x plus 13, because I've just simply moved that minus 3x to the other side. You can call this 3. So I'm going to substitute 3 into 1. So I get x squared plus 3x plus 13 squared equals 25. So now I just want to start to rewrite. So 3x plus 13 by opening up and expanding the brackets equals 25. So if I just use my arrows, so again just expanding, so expand. So I'll get 9x squared plus 39x plus 39x plus 169 equals 25. So now I can collect like terms. So 10x squared from these two plus 78x plus 169 minus 25 equals 0, because I've brought this to the other side, so it's a negative minus 25. So 10x squared plus 78x plus 144 equals 0. Right, so the next step is I use the product sum method. Okay, now I can see that these are all even, so I divide by 2 to give us 5x plus 39x plus 72 equals 0. Product sum, so it means I need 2 numbers, okay, which gives me product of 5 times 72, which is 360, but 2 products sum of 39. So I go through all of the factors of 360, and there's going to be a few, but I know if you work through it that you're going to get 15 and 24, which abide by this criteria. So I put 5x squared, referring back to this here, 5x squared plus 15x plus 24x plus 72 equals 0. So now I start to factorize. So I can put the 5 outside, and then the x also, and then x plus 3. Then here I would have plus 24, and then I put x plus 3 equals 0. So I'm going to have x plus 3, and then I combine the others, so 5x plus 24. So just combine the coefficients of the 2 brackets to give us our final bracket. So x is going to be minus 3, or x will be minus 24. I'll write that out more neatly. Minus 24 over 5. Okay, so now I need to take these values of x and put them in to find my value of y. So let's use 2. Let me try a different color. So use 2 for x equals minus 3 and x equals minus 24 over 5. So let's say y equals 3, and I'm going to put x equals minus 3 in plus 13. So this gives me minus 9 plus 13, which gives me 4. And then for this one here, y equals 3 minus 24 over 5 plus 13. So that equals minus 72 over 5 plus 13. So now if I'm going to convert 13 into a fraction, so 65 over 5. So I have minus 72 plus 65, which gives me minus 7 over 5. So therefore, this means when x equals minus 3, y equals 4, or when x equals minus 24 over 5, y equals minus 7 over 5. Okay, question 21. So it says here ABCD is a quadrilateral. AB equals CD, and you can see these dashed lines there, which means they're same length, and angle ABC is the same as BCD. So these two are the same because they're the same length, and this is a horizontal line, so that means that these angles are going to be the same. So prove that AC, this line here, and BD are equal. So essentially what it wants to know is prove that the line BD, which should be straight, okay, prove that these two lines are equal. Right, so we know that AB and CD are equal. It's given to us. And we know that the angle ABC is equal to angle BCD, right? So BC is common to both triangle ABC and BCD. Okay, so what I mean by that is BC, right, is common to both ABC and BCD. So therefore triangle ABC and BCD are congruent. So then that means SAS, and therefore AC equals BD. And this just means that, if you remember from before, that SAS refers to side, angle, side. Okay, and where we have a side, angle, side, it means that you have two triangles where we know two sides and an equal angle. And as we mentioned before, this allows us to prove that AC equals BD. Okay, because we have this side here, this angle here, and this side here, and likewise we have this side here, this angle here, and this side here. Okay. Okay, question 22. So since the working out for this question is slightly longer than usual, I will do it on a different software. So question 22, it says the diagram shows a hexagon A, B, C, D, E, F, and you have it here. It shows that A, B, E, F, and C, B, E, D are congruent parallelograms. So essentially A, B, E, F is the same as C, B, E, D in that they're congruent parallelograms. Where A, B, and B, C, so A, B, and C, B are equal to X, and point P is the point on AF, which is here, and Q is the point on CD, such that BP and BQ are equal to 10. Right, so equal to 10, equal to 10. Given that ABC, so we've got ABC, so that's there, 30. Probably should use a different color. Prove this. So we've got cos PBQ. Okay, so let's prove it. So let's draw our triangles. So we've got a triangle here. Let's call this ABC. We know that's going to be 30. We know this is X. This is X here. And then we have another triangle, which is P, B, and Q. And we know this is going to be P, B, and Q. We know that the lengths are 10 on BP and BQ, because we're told that. And so we want to, first of all, first step that I'm going to do is, so step 1. So I'm going to find AC in terms of X. So I'm going to find this one here in terms of X. So I'm going to use, because we're talking about cosine here, I'm going to use the cosine rule for finding the lengths. So a squared equals b squared plus c squared minus 2bc cos a. And I'm going to have completing this and subbing in the relevant details. 2x squared. Now cos a and in this case a is 30 equals the square root of 3 over 2. So I have the square root of 3 over 2. And we finish this off. It's collecting like terms. 2x squared. 2x squared. And now if we factorize 1 minus square root of 1 minus square root of 3 over 2, and then we know for a fact that AC equals PQ because AC there and PQ are the same because they're on the distance between the two are based on a parallelogram. Okay, so if we want to find PBQ, we can say cos A equals, and again we can use the formula, the cosine formula for finding the angle. So we get cos PBQ equals, remember we refer back to our triangle here, so we had the sides equal to 10. So 10 squared plus 10 squared minus, so now we have the a squared. So for the a squared we're going to use what we had here before. So 2x minus 2x squared square root of 3 over 2. Okay, and then this is going to be over 2bc, so 210 times 10. So this is going to equal, so this is 100, so that's 200. Keep the brackets as is. And then that's over 200. Now, what we can do is we separate, Let's do this. So we essentially want something like this. See, we've got over 200. So essentially what we can do is we can separate into two different fractions as follows. So we get this equals 1 minus 2x squared minus 2x squared square root of 3 over 2 over 200. Brilliant. So let's compare that to what we want here. And then the x squared is outside. So x squared goes outside. So 1 minus, and then we said 2x squared. Now the other thing is we can cancel these two here. Square root of 3. We're going to put the x squared outside over 200. And we can see that's exactly what we have. So cos PBQ equals 1 minus, and then this fraction here to the power next to x squared, and that's what we've got here. And that brings us to the end of the exam.